Hi, welcome to this Blender video tutorial entitled Blender Lighting Point Lamp. Blender's point lamp object is an omnidirectional point source of light. To demonstrate Blender's point lamp, I have placed in my scene a model sculpture and a base placed on a flat plane. The sculpture has a gold material attached to it, and the base a model blue material, and the plane a cherry wood texture. In the World Editor, I have added a blue blended sky gradient. I've split my 3D editor into two windows, placing the UV image editor on the right, and have set the render output to display the rendered image in this UV image editor. I'll render the scene. Now, as the scene has no lighting objects, the sky is displayed, leaving the sculpture, base, and plane in silhouette. I'll place my 3D cursor in the top view and add a point lamp object. In the front view, I'll move it to about the height of the camera, and I'll render the scene. The point lamp is omnidirectional, casting light in all directions from its location point. Notice that the point lamp icon in the 3D viewport editor is a black dot inside of a circle. I will click on the Object Data icon in the Properties editor, which displays all the point lamp controls. Most of these controls are common to all Blender lamp objects. In the Preview panel, we can see a general preview of the lamp output that shows a soft, rather weak center of light that fades to black over distance. The point lamp's directionality effect is dependent upon its location in the scene relative to the objects. Its intensity effect is dependent on its distance from the objects. I'll move the point lamp to the other side of the sculpture and re-render. I'll now move the point lamp to underneath the sculpture and the plane and re-render. Notice that the light goes through the plane and the base objects to illuminate the underside of the sculpture. I'll now move the lamp back to its original position. In the lamp panel, there are 5 lamp buttons that allow the point lamp to be changed to any of Blender's 5 lamp type objects: a sun lamp, a spot lamp, a hemi lamp, an area lamp, or back to the point lamp. Below these lamp buttons is the point lamp color swatch, which is by default set to white. Now, in the real world, light is seldom pure white. The color setting is often used to create a warm or a cool color light, reflecting the time of day or the surrounding environment. I'll lower the red to about 0.3 and the green to about 0.5, making a much cooler light color. I will then render the scene. Now, since the gold sculpture has little blue diffuse color in it, it reflects back little light and thus appears more gray. The blue base has much blue color in it, and thus it stands out. I'll set the point lamp color back to white. Below the color swatch is an energy setting, which by default is set to 1. Here we can raise the intensity of the light energy, making it brighter, and thus brighter over distance. I'll set the energy level to 4 and re-render the scene. Note the scene is considerably brighter. I'll return the energy setting back to 1. Below the energy controller is the fall-off controls. The fall-off is the distance from the light source in Blender units where the intensity of the light will be 1/2 the original. Now, by default, this distance is set to 25 Blender units. Generally speaking, decreasing this distance will cause the objects to appear dimmer because the fall-off is quicker. Increasing this distance will cause the objects to appear brighter because the fall-off is slower. By default, the equation used to determine the fall-off is set to inverse square, which causes a rather rapid fall-off of intensity. It is possible to change this fall-off to a different equation by clicking on the fall-off type box and choosing a different equation, including a custom curve option. When the custom curve option is selected as the fall-off, an additional panel is displayed called the fall-off curve. Here you can set a custom fall-off pattern. Clicking on the curved line adds control points that can be moved. Here I will add a control point and set the curve for a rather drastic fall-off. And then render the scene. I'll set the fall-off back to inverse square and move the point lamp object so that it is inside the lower portion of the sculpture. I'll then set the fall-off distance to 1 blender unit and render the scene. Here, because of the placement and fall-off of the lamp, the lighting focuses on the center of the sculpture and fades away outward rapidly from there. We can isolate the point lamp even more by checkmarking the sphere box. This limits the extent of the light to a sphere indicated in the 3D viewport as a dotted sphere shape. The diameter of the sphere is determined by the distance setting. Rather than a fall-off point, the sphere is a blackout point. No light will escape from the extent of the sphere. I'll render the scene. Note that the lighting effect is limited to the extent of the sphere. I will uncheck the sphere checkbox and set the fall-off distance back to 25 blender units. And I'll return the point lamp to its original position. To the right of the fall-off controls are 4 checkboxes. The specular and diffuse boxes are checked by default. These enable or disable the light's effect on the object's diffuse or specular reflections. The This Layer checkbox limits the lamp's effect to objects located on the same layer as the lamp object. The Negative checkbox reverses the illumination power of the lamp object, in effect emitting darkness rather than light. To demonstrate this, in top view, I will make a duplicate of the point lamp object and move it to the other side of the sculpture. I will then checkmark the negative checkbox on the original lamp. I'll then render the scene. Note that the lamp acts as a darkness-emitting lamp, darkening the right side of the rendering. I'll delete the new point lamp object and uncheck the negative checkbox. By default, the point lamp has its shadow control turned off. I'll press the Ray Shadow button and render the scene. Notice that the shadow of the sculpture is now displayed on the tabletop plane. Note also that the icon in the 3D viewport editor now has a dotted circle around the enclosed circle. You can tell at a glance if any point lamp in your scene is set to produce shadows by this dotted circle. Note also that the shadows are ray-traced shadows. In order to render these shadows, the Ray Shadow button in the lamp's Shadows panel must be activated, and the Ray Tracing checkbox in the Render Shading editor must also be checkmarked, which it normally is by default. When the Ray Shadow button is activated, additional controls are displayed in the lamp's Object Data Editor. The first of these controls is a color swatch, which by default is set to black. This allows the shadows to be colored. I'll set the shadow color to a blue. I'll then re-render the scene. Note that the shadow is not colored so much as rather the color of the shadow is changed to blue. The blue diffuse base, which has a lot of blue in it, picks up the blue shadow. But the table plane, that has very little blue in its diffuse color, displays a more dark gray colored shadow. I will set the shadow color back to black. I'll go to front view and place the point lamp back underneath the table plane. Remember when I demonstrated this earlier, the light passed through the plane, illuminating the bottom of the sculpture. I'll render the scene again. Note that with the lamp's shadows turned on, the shadow cast by the plane itself eliminates any lighting of the sculpture. I'll turn off the shadows and render again. I'll return the point lamp to its original position and turn back on the Ray Shadow. The This Layer checkbox limits shadows to be cast by objects only in the same layer as the lamp object. The Only Shadow checkbox causes the point lamp to cast shadows but not illuminate objects. Below this are sampling controls, which determines the method in which the shadows are calculated. By default, this is set to Adaptive QMC. Now both are quite good sampling controls. I'll select the constant QMC and render the scene. Note the hardness of the shadow. Now I'll go back and increase the softness setting to 1.5 and the samples to 2. And then re-render the scene. Notice now that the shadows are much softer. Blender's point lamp can also have a texture applied to it. With the lamp selected, I will click on the texture icon in the Properties panel. I'll add a new texture, and I'll use the default clouds as my texture type. I'll change the preview to lamp, and I'll set the influence color to black. In the Clouds panel, I'll select Hard and change the size to 4. In the Mapping panel, I'll set the X, Y, and Z size to 6, in effect zooming in on the cloud pattern. I'll then render the scene. Note that the point lamp now has a dappled effect caused by the influence of the cloud texture. Both my sculpture and the table plane have a slight mirror effect in their materials. I'll select the sculpture object, go to the Materials Editor, and turn on the mirror effect. I'll do the same with the table plane object. I'll then render the scene.